welcome to 10.2, acid and base reactions. 10.1. We're going to go over example number 2 now. And so at the beginning of this example, there's a paragraph that says, whenever an acid is combined with a base, and at least one of them is strong, we can consider that neutralization reaction goes to completion. Right? So whenever you combine an acid and a base, it's usually going to neutralize and make water at some point. However, if one of them is weak, then an equilibrium process follows. So this is important. If one of them is weak, there's an equilibrium process that follows. For these processes, we have to follow the following steps. So 1, 2, and 3. And so for our first step, it's going to find the moles of the initial substances. That one's pretty easy. I'll color code these. For our second step, we need to use stoichiometry to describe the reaction mixture when the reaction goes to completion. And for our third step, we need to figure out, there we go, we need to use the concentrations for the equilibrium step. All right, so let's go ahead and go through example 2. There's a couple different parts to this. If the video gets too long, I'll split it up into 2 separate videos. So example 2, it says, suppose a 0.1 molarity sodium hydroxide solution is added to a 40 milliliter of a 0.1 molarity acetic acid solution. The Ka of acetic acid is 1.8 times 10 to the negative 5th. Find the pH of the solution when, and then there's a whole bunch of scenarios that follow. So for part A, no sodium hydroxide has been added, 10 milliliters of sodium hydroxide has been added, 20 milliliters has been added, 30 milliliters, 40 milliliters, and then part F is 60 milliliters. And after we've done all that, we want to sketch the graph to see how it looks like. All right, so for the very first part, no sodium hydroxide has been added to this equation, which means we just have acetic acid, and if we just have acetic acid, it's going to be slightly acidic. So I'm going to go ahead and write that. It's going to be slightly acidic because we just have acetic acid. We haven't added any NaOH. So for this one right here, we're going to go ahead and just do a normal icebox table. And so our icebox table, we're going to start with our equation. We have acetic acid, and since it's just acetic acid, I'm going to write that it splits apart slightly, right? Less than 5%, so back and forth arrows. We have H positive, and then acetate, which is C2H3O2 minus. We have our ice table. Our ice table in this case is going to be based on molarity. And so our molarity for these ones are right here. We have 0.1 acetic acid, so that's what we have initially. So 0.1 molarity. We don't have any of our product yet, so 0 and 0. We have minus X, we have plus X, we have plus X. At the equilibrium, we have 0.1 minus X, X, X. All right, we need to set up our Ka. The reason it is a Ka is because it has hydrogen right here. And so we know that it's an acid. So our Ka is our products over reactants. So we have hydrogen and then acetate. I'm going to abbreviate acetate as A minus, just so I don't have to keep writing C2H3O2 minus. And then on the bottom, we have acetic acid, which is HC2H3O2 minus, and I'm abbreviating that as HA. All right, plugging in our Ka was given to us right here. It's 1.8 times 10 to the negative 5th. On the other side, H and A, so hydrogen and acetate, are both X. On the bottom part of our fraction, we have 0.1 minus X. We can ignore the minus X because X will be really small, so it's negligible. So we can just plug in 0.1 to save some time. Cross multiply 0.1 to 1.8 times 10 to the negative 5th, and then square root it, and you end up with X equals, pause the video if you want to do it in your calculator yourself, but it should equal 1.3. Let me go back. 1.3 times 10 to the negative 3. All right, that one's easy. And then in order to find our pH, because the whole point of this entire problem, all of these parts, is we need to find the pH when, so we're finding the pH for all of these. And so since X is this, and we know that X is also hydrogen at the endpoint, we can just take the negative log of that. And so go ahead and pause the video, make sure you have the correct answer. But when you get negative log of 1.3 times 10 to the negative third, you end up with 2.89. And so that's our pH, 2.89. All right, for part B, we need to use 10 milliliters now of NaOH that has been added. And we need to figure out what the pH of the solution is at that point. All right, so our very first step is we need to find the moles of acetic acid and the moles of hydroxide. So the moles of acetic acid is just the molarity times the liters. And so if we scroll back up here, the moles of acetic, the volume, the milliliters of acetic acid was 40 milliliters, and the molarity is 0.1, and I'm getting that from right here. So 40 milliliters times 0.1, and we also know that sodium hydroxide is 0.1. All right, so moles of acetic acid is going to be 0.040 liters, so I converted the milliliters to liters, times the molarity of it, and it was 0.10. When you multiply that out, you end up with 0.004, and if you're doing significant figures, add a 0 at the end, moles. All right, the moles of hydroxide, same thing. We have 10 milliliters. I'm going to convert that to liters, so 0.010 liters. And the molarity up above was 0.10. So when you multiply those two together, you end up with 0.0010. And that's of hydroxide. All right, for this one, we are going to go ahead and plug it into our ice table. Our ice table, we need to have our equation. And so our equation comes from example 1, where we had acetic acid. And I'm actually going to abbreviate acetic acid as HA just to make my life simpler. We have OH minus. It yielded acetate, so I'm going to abbreviate acetate as A minus, and water. Right, and so we're going to create our ice table based off of this. For this one, though, our ice table is in moles instead of molarity. So just be careful with that because we need to divide by the total amount of liters at the end. And so initially, for acetic acid, we have 0.004. And for hydroxide, we have 0.001. We don't have any acetate yet because it's the initial. And water is liquid, so we can ignore it. We're going to subtract the smallest number. Whenever we have moles for icebox, we can subtract the smallest number. And so we are going to subtract 0.001. And we're going to add that same number to the other side. All right, and because it's the smallest one, it's the limiting reactant. So whichever one is the smallest, we're going to run out of that first. So we have 0 hydroxide. We have 0.003 acetic acid. And we have 0.001 moles of acetate. All right. The next step that we can use is called the Henderson-Hasselbalch equation. And so the Henderson-Hasselbalch equation is the following. We have pH is equal to the pKa plus the positive log of the concentration of acetate, or the conjugate, divided by acetic acid, or the weak acid. So your conjugate will always go on the top, your weak acid will always go on the bottom. And this equation is given to you on the equation sheet. So we're going to go ahead and plug in everything that we know at this moment. So we need to find the concentration of acetate, and we need to find the concentration of acetic acid first. We know that both of these has, for acetic acid is 0.003 moles, For acetate, it's 0.001 moles, but we need to plug in the concentrations, not the moles. So we need to divide it by the total liters. And so our concentration of acetic acid would be 0.001 moles divided by the total amount of liters. And the total amount of liters is 10 from sodium hydroxide and 40 from acetic acid. So 40 plus 10, there's 50 milliliters in total right now. And I'm going to convert that to liters. And so when we divide those two right there, we end up with 6 times 10 to the negative 2. And for acetic acid, so HA, so HC2H3O2, that's acetic acid. The concentration of that one is going to be our 0.003, and that's our moles on the top. And again, we're dividing by the total amount of volume. So 0.05 liters, so 50 liters, 10 plus 40. When you divide those two, you end up with 2 times 10 to the negative 2. And that's molarity. Right, so now we have the concentration of acetic acid, or the weak acid, so we can plug that in. We have the concentration of acetate, or the conjugate, so we can plug that in. We have the Ka, and we know that pKa, anytime you have a P, is just the negative log. So let's go ahead and plug that in right now. Okay, so we have our pH is equal to negative log, because that's what P stands for. And our Ka from up above was 1.8 times 10 to the negative 5th. And we're adding that to the log of the acetate, the conjugate, divided by acetic acid, the weak acid. And we're plugging in the molarities right here. And so acetate was 6 times 10 to the negative 2, divided by acetic acid, which is 2 times 10 to the negative 2. All right, go ahead and pause, simplify that in your calculator, make sure you get the correct answer. You should end up with approximately 4.26. And there you go. Alrighty. The important thing here for the Henderson-Hasselbalch equation is that because it is a weak acid and a conjugate of a weak acid, we can use the Henderson-Hasselbalch to make our lives simpler. And so this equation is extremely important when we have buffer solutions. So a weak acid with a conjugate base. Alrighty, scrolling down to C. So this is C right here. We are adding 20 milliliters now, and so we're going to do the same thing. I would like you to pause and try this one out yourself, but it's the same steps as up above. So we're going to find the moles, do our ice table, and our ice tables in moles, find our concentrations, and then plug it into the Henderson-Hasselbalch equation. Okay, so our moles of acetic acid is going to be the exact same as up above. We have 0.04 liters, and we have 0.1 molarity. And so that's just going to give us the same amount, 0.004 moles. The moles of hydroxide, now we have 20 milliliters, which is 0.02 liters. And we still have 0.1 molarity for hydroxide. We're getting that concentration from up above. And so now we have 0.002 moles. All right, the next step is to set up our ice table. And so we have acetic acid plus hydroxide, and then acetate plus water. Ice table. Right, and we're plugging in moles, so we need to make sure we divide by the total liters at the end in order to get concentration. Okay, cross out water. Acetic acid is 0.004. Hydroxide is 0.002. We don't have any acetate. We're going to subtract hydroxide because it's the smaller number. So 0.002 gets subtracted on the left side, and it gets added on the right side. And so